and CEO Jensen Huang.
Washington, D.C. Washington, D.C., welcome to GTC. It's hard not to be sentimental and proud of America, I got to tell you that. Was that video amazing? Thank you. NVIDIA's creative team does an amazing job. Welcome to GTC. We have a lot to cover with you today. GTC is where we talk about industry, science, computing, the present, and the future. So I've got a lot to cover with you today. But before I start, I want to thank all of our partners who helped sponsor this great event. You'll see all of them around the show. They're here to meet with you. And really great. We couldn't do what we do without all of our ecosystem partners. This is the Super Bowl of AI, people say. And therefore, every Super Bowl should have an amazing pregame show. What do you guys think about the pregame show and our all-star athletes and all-star cast? Look at these guys. Somehow, I turned out the buffest. What do you guys think? I don't know if I had something to do with that. NVIDIA invented a new computing model for the first time in 60 years, as you saw in the video. A new computing model rarely comes about. It takes an enormous amount of time and set of conditions. We invented this computing model because we wanted to solve problems that general-purpose computers, normal computers, could not. We also observed that someday, transistors will continue. The number of transistors will grow, but the performance and the power of transistors will slow down. That Moore's law will not continue beyond, limited by the laws of physics. And that moment has now arrived. Dennard scaling had stopped. It's called Dennard scaling. Dennard scaling has stopped nearly a decade ago. And in fact, the transistor performance and its power associated has slowed tremendously. And yet, the number of transistors continued. We made this observation a long time ago, and for 30 years, we've been advancing this form of computing we call accelerated computing. We invented the GPU. We invented the programming model called CUDA, and we observed that if we could add a processor that takes advantage of more and more and more transistors, apply parallel computing, add that to a sequential processing CPU, that we could extend the capabilities of computing well beyond. And that moment has really come. We have now seen that inflection point. Accelerated computing, its moment has now arrived. However, accelerated computing is a fundamentally different programming model. You can't just take a CPU software written by hand, executing sequentially, and put it onto a GPU and have it run properly. In fact, if you just did that, it actually runs slower. And so you have to reinvent new algorithms. You have to create new libraries. You have to, in fact, rewrite the application, which is the reason why it's taken so long. It's taken us nearly 30 years to get here. But we did it one domain at a time. This is the treasure of our company. Most people talk about the GPU. The GPU is important. But without a programming model that sits on top of it, and without dedication to that programming model, keeping it compatible over generations, we're now CUDA 13 coming up on CUDA 14. Hundreds of millions of GPUs running in every single computer, perfectly compatible. If we didn't do that, then developers wouldn't target this computing platform. If we didn't create these libraries, then developers wouldn't know how to use the algorithm and use the architecture to its fullest. One application after another. I mean, this is really the treasure of our company. CULitho, computational lithography. It took us nearly 7 years to get here with CULitho, and now TSMC uses it, Samsung uses it, ASML uses it. This is an incredible library for computational lithography, the first step of making a chip. Sparse solvers for CAE applications. cuOpt, a numerical optimization, has broken just about every single record. the traveling salesperson problem, how to connect millions of products with millions of customers in the supply chain. Warp, Python solver for CUDA, for simulation. CUDF, a data frame approach, basically accelerating SQL, data frame databases. This library is the one that started AI altogether, cuDNN. The library on top of it, called Megatron Core, made it possible for us to simulate and train extremely large language models. The list goes on. MONAI, really, really important. The #1 medical imaging AI framework in the world. By the way, we're not going to talk a lot about healthcare today, but be sure to see Kimberly's keynote. She's going to talk a lot about the work that we do in healthcare. And the list goes on. Genomics processing. Ariel, pay attention. We're going to do something really important here today. Quantum computing. This is just a representative of 350 different libraries in our company. And each one of these libraries redesigned the algorithm necessary for accelerated computing. Each one of these libraries made it possible for all of the ecosystem partners to take advantage of accelerated computing. And each one of these libraries opened new markets for us. Let's take a look at what CUDA X can do.
Ready, go!
Is that amazing? Everything you saw was a simulation. There was no art, no animation. This is the beauty of mathematics. This is deep computer science, deep math, and it's just incredible how beautiful it is. Every industry was covered, from healthcare and life sciences to manufacturing, robotics, autonomous vehicles, computer graphics. even video games. That first shot that you saw was the first application Nvidia ever ran. And that's where we started in 1993. And we kept believing in what we were trying to do. And it's hard to imagine that you could see that first virtual fighter scene come alive. And that same company believed that we would be here today. It's just a really, really incredible journey. I want to thank all the Nvidia employees for everything that you've done. It's really incredible. We have a lot of industries to cover today. I'm going to cover AI, 6G, quantum, models, enterprise computing, robotics, and factories. Let's get started. We have a lot to cover, a lot of big announcements to make, a lot of new partners that would very much surprise you. Telecommunications is the backbone, the lifeblood of our economy, our industries, our national security. And yet, ever since the beginning of wireless, where we defined the technology, we defined the global standards, we exported American technology all around the world so that the world can build on top of American technology and standards. It has been a long time since that's happened. Wireless technology around the world, largely today, deployed on foreign technologies. Our fundamental communication fabric built on foreign technologies. That has to stop. And we have an opportunity to do that, especially during this fundamental platform shift. As you know, computer technology is at the foundation of literally every single industry. It is the single most important instrument of science. It's the single most important instrument of industry. And I just said, we're going through a platform shift. That platform shift should be the once-in-a-lifetime opportunity for us to get back into the game, for us to start innovating with American technology. Today we're announcing that we're going to do that. We have a big partnership with Nokia. Nokia is the second largest telecommunications maker in the world. It's a $3 trillion industry. Infrastructure is hundreds of billions of dollars. There are millions of base stations around the world. If we could partner, we could build on top of this incredible new technology, fundamentally based on accelerated computing and AI, and for the United States, for America to be at the center of the next revolution in 6G. So today we're announcing that Nvidia has a new product line. It's called the Nvidia ARC, the Aerial Radio Network Computer. Aerial RAN Computer, ARC. ARC is built from three fundamental new technologies: the Gray CPU, the Blackwell GPU, and our ConnectX, Mellanox ConnectX networking designed for this application. And all of that makes it possible for us to run this library, this CUDA-X library that I mentioned earlier called Aerial. Aerial is essentially a wireless communication system running on top of CUDA-X. We're going to create, for the first time, a software-defined, programmable computer that's able to communicate wirelessly and do AI processing at the same time. This is completely revolutionary. We call it Nvidia ARC. And Nokia is going to work with us to integrate our technology, rewrite their stack. This is a company with 7,000 fundamental, essential 5G patents. Hard to imagine any greater leader in telecommunications. So we're going to partner with Nokia. They're going to make Nvidia ARC their future base station. Nvidia ARC is also compatible with AirScale, the current Nokia base stations. So what that means is we're going to take this new technology and we'll be able to upgrade millions of base stations around the world with 6G and AI. Now, 6G and AI is really quite fundamental in the sense that for the first time, we'll be able to use AI technology, AI for RAN, to make radio communications more spectral efficient. using artificial intelligence, reinforcement learning, adjusting the beamforming in real time in context, depending on the surroundings and the traffic and the mobility, the weather. All of that could be taken into account so that we could improve spectral efficiency. Spectral efficiency consumes about 1.5% to 2% of the world's power. So improving spectral efficiency not only improves the amount of data we can put through wireless networks without increasing the amount of energy necessary. The other thing that we could do, AI for RAN, is AI on RAN. This is a brand new opportunity. Remember, the internet enabled communications, but amazingly smart companies, AWS, built a cloud computing system on top of the internet. We are now going to do the same thing on top of the wireless telecommunications network. This new cloud will be an edge industrial robotics cloud. This is where AI on RAN, the first is AI for RAN to improve radio spectrum efficiency. The second is AI on RAN, essentially cloud computing for wireless telecommunications. Cloud computing will be able to go right out to the edge where data centers are not, because we have base stations all over the world. This announcement is really exciting. Justin Hodar, the CEO, I think he's somewhere in the room. Thank you for your partnership. Thank you for helping the United States bring telecommunication technology back to America. This is really a fantastic, fantastic partnership. Thank you very much. That's the best way to celebrate Nokia.